Hello students. So the purpose of this lecture is to cover one of the last topics that we'll hit in this class, the double and half angle identities for trig functions. So the double angle formulas, appropriately enough, say what happens to trig functions when you multiply an angle by 2. And, well, where do those formulas come from? They just come from angle addition. So let's start by recalling angle addition. For any two angles A and B, the cosine of A plus B is, well, you remember this, so you can fill this out on your own. Cosine A, cosine B, minus sine A, sine B. Sine of A plus B is sine A cosine B plus cosine A sine B. Tangent of A plus B is tangent A plus tangent B divided by 1 minus tangent A times tangent B. So 2 theta is the same thing as theta plus theta. So I can use angle addition to get double angle formulas. So let's do exactly that for each of these. Cosine of 2 theta, that's the same thing as cosine of theta plus theta. So I can take this button, the angle addition formula, take A equal to theta and B equal to theta and get cosine of theta plus theta, that's the cosine of 2 theta. And then I can use this formula on the right where A and B are both theta. So this will be equal to cosine theta times cosine theta minus sine theta, also known as cosine squared theta minus sine squared theta. And unlike the others, there will be 3 versions that I'll write of the double angle formula for cosine. So there is version 1 of the double angle formula for cosine. And I say version 1 because you'll notice something about this. It looks like if I want to use the double angle formula for cosine, I need to know both cosine and sine of theta. Maybe you think that's a little bit annoying. Sometimes it's unavoidable, but whenever you see that situation, you should hope that it isn't. Well, sine squared, I can replace that by 1 minus cosine squared. So here's another version of the double angle formula for cosine you can get by saying, well, sine is the same thing as 1 minus cosine. Sine squared is 1 minus cosine squared. So this is cosine squared theta minus 1 minus cosine squared theta. And of course you should simplify that, right? You would distribute that minus sign, turn that thing in parentheses to minus 1 plus cosine squared theta. And what do you wind up with? You wind up with 2 cosine squared theta minus 1. And here, this is version 2 of the double angle formula for cosine. And I'll go ahead and just write down what the last one is. The last version of this that you can get is 1 minus 2 sine squared theta. And the way you get that is the exact same, but instead of replacing sine squared with 1 minus cosine squared, you replace cosine squared with 1 minus sine squared. So there's the double angle formulas for cosine. Let's now do sine and tangent. So the sine of 2 theta, as you see up above, will just be sine theta cosine theta plus sine theta cosine theta. So all I did there is I used this formula where A is theta and B is theta. Theta plus theta is 2 theta, so I'll see sine theta cosine theta plus cosine theta sine theta. And, well, it doesn't matter what order you multiply. Well, okay, so they're both sine then cosine. So this will be the same thing as 2 sine theta cosine theta. So the double angle formula for sine says sine of 2 theta is the same thing as 2 sine theta cosine theta. Finally, tangent. The tangent of 2 theta will be the same thing as, reading off the formula for tangent, it will be tangent theta plus tangent theta. So that's 2 times tangent theta all over 1 minus tangent theta tangent theta. So that's 1 minus tangent squared of theta. And there's the double angle formula for tangent. And something that's nice to notice is that means that if you want to use the double angle formula for tangent, you just need to know what tangent of theta is. You don't need to know like sine and cosine, you just need to know tangent. So let's see just a quick application. Let's suppose that you know that sine of theta is 3/5, and theta lives between negative pi over 2 and pi over 2. Negative pi over 2, pi over 2 and pi. Let's try to compute cosine 2 theta, sine 2 theta, and tangent 2 theta. So something to notice immediately is you know what sine and this is enough information to compute sine of theta and cosine of theta. And if that's enough information to compute sine of theta and cosine of theta, then that's enough information to use these double angle formulas. So let's do that. Sine of theta is 3/5. That's a given. Cosine of theta, well, we've done this enough times that you probably already know that it's going to be negative 4/5, but let's go through the walk. So to find cosine of theta, you'll use the fact that cosine squared theta plus sine squared theta is always 1. So cosine squared theta plus sine of theta is 3/5, so sine squared of theta will be 9 over 25 is equal to 1, which I'll go ahead and write as 25 over 25. We'll subtract the 9 over 25 to the other side. We'll get cosine squared theta equal to 25 minus 9 is 16 over 25. So cosine theta is plus or minus the square root of that, plus or minus 4 over 5. And this angle lives between negative pi over 2 and pi over 2. So the negative choice will be correct. Even though we've done exactly that computation several times, I still think it's worth going through. And I guess we may as well also write down tangent of theta. Tan theta is given by sine over cosine. That's 3 over negative 4. I'll write that as negative 3 over 4. Now we have everything we need to use the double angle formula. So let's use the double angle formula to compute cosine first, because that's the first one that's written. The cosine of 2 theta, well, we can use any of the formulas, but you know what, as long as we know what sine of theta and cosine of theta is, let's use the formula that uses them both. Let's use version 1, so cosine squared theta minus sine squared theta. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta. Now we'll plug in the givens. Cosine of theta is negative 4/5, so this will be negative 4 over 5 squared minus sine of theta squared, 3 over 5 squared. Notice that minus sign. So this will be, let's see, negative 4 squared is 16. The negative sign goes away. 16 over 5 squared is 16. No, 5 squared is 25. Minus 3 squared is 9. 5 squared is 25. I have a common denominator. That's good. And the numerator will just be 16 minus 9. That's 7. Cosine of 2 theta is 7 over 25. Next, let's compute the sine of 2 theta. So the sine of 2 theta, we don't have any freedom. The only formula we have is that this is 2 sine theta cosine theta. All right, well, I know what sine and cosine is. That's 2 times. Sine of theta is 3/5. Cosine theta is negative 4/5. Those are all multiplied together. So the whole thing will wind up being negative. Positive times negative will be negative. The denominator is 5 times 5 is 25. The numerator is 2 times 3 is 6. 2 times 3 is 6 times 4 is 24. Nice. And finally, let's compute tangent. And I'll do this 2 different ways. I've already computed sine 2 theta and cosine 2 theta, so I could just use that. I also have a double angle formula for tangent. I could use that. I'll go ahead and use the double angle formula first. Just that's the one that's the most novel. So tangent of 2 theta is 2 times the tangent of theta divided by 1 minus the square of the tangent of theta. And let's just plug in. I know what tangent of theta is. It is negative 3 over 4. So that'll be 2 times negative 3 over 4 divided by, parentheses matter, put them in, 1 minus negative 3 over 4 squared. And this will require some simplification. So let's see. The numerator, I multiply by 2 and then I divide by 4. That's the same thing as just dividing by 2. So that's negative 3 over 2 all over 1 minus negative 3. This negative sign will go away because it's being squared. 3 squared is 9, 4 squared is 16. So that's negative 3 over 2 all over, let's see, 1, I can rewrite that as 16 over 16. 16 minus 9 is 7 over 16. And now, well, I see a fraction divided by a fraction. Division by a fraction is the same as multiplication by the denominator, by the reciprocal of the denominator. So that's negative 3 over 2 times 16 over 7. 16's even. 16 is 2 times 8. So that'll be negative 3 times 8 over 7. That's 24, because 3 times 8 is 24 over 7. Oh, remember the negative sign, Chris. There it is. On the other hand, another way of doing that same computation, my handwriting was too big and cartoonish for there to be space right here. Alternately, tangent of 2 theta is equal to sine 2 theta divided by cosine 2 theta. And I know what those two things are. Sine of 2 theta is negative 24 over 25 all over 7 over 25. The numerator and denominator are both divided by 25, so those will cancel. If you feel uncomfortable with fractions, then yeah, maybe you want to like multiply by the reciprocal, but then you'll cancel the 25s immediately anyway, and you'll end up with negative 24 over 7. Nice, which is consistent. So that should make you feel more confident in the answers. Maybe we'll do one more just quick sanity check. Let's think about where this angle is so we can think about where it'll be when we double it. So let's draw this thing in the unit circle. So sine is 3/5 and cosine is negative 4/5. So there's the angle theta. So it looks like when we double it, so it's a little bit bigger than 3 pi over 4. So we go and double it. 3 pi over 4 will double to 3 pi over 2. So 2 theta will be a little bit past that. So that's quadrant 4. So it looks like cosine should be positive, sine should be negative. Cosine positive, sine negative, tangent negative. Okay, I'm pretty confident in the answer now. So the other formula that I want to talk about today. Oh, so maybe this is a good place to pause the video. I'm going to stop it here. We'll come back and talk about the half angle identities. Talk to you soon.